Good morning. Welcome to my channel Math of Physics Academy. And today I have brought from chapter 6 of Physics CBSE 12th standard, Electromagnetic Induction. Electromagnetic induction as given in chapter 6 of 12th standard physics is a very important chapter. Of course, other chapters are too important. In this video, I am going to discuss an introduction part and especially that Faraday's 3 laws. Let us move. Once again, I am informing that these pictures are being taken from NCERT textbook. And the credit goes solely to the creator. Wholly to the creator. I have taken the picture from NCERT textbook just for reference and to describe for academic purpose. Right? Fine. So, electromagnetic induction, what actually it is? So, electromagnetic induction is a process. First one, it is process. It is a process. So now, in this process, what happens? To generate an induced EMF, electromotive force. Okay, it is a process in which induced EMF is generated and hence induced current, we can say, and hence induced current is generated in a coil, in a closed loop, in a closed wire loop. Okay. Right. But how? Now the question arises, how? So by varying magnetic field, by varying magnetic flux, which is nothing but magnetic field in an area. So by varying magnetic flux associated with the loop. So this is called electromagnetic induction. So this electromagnetic induction, which is a process, which is a phenomena to generate an induced EMF and hence induced current in a closed wire loop by varying magnetic flux associated with the loop. So, to do that, Michael Faraday and Joseph Henry. Michael Faraday and Joseph Henry in USA, they performed some experiments and they found that by varying magnetic field or magnetic flux, a small induced EMF can be generated in a closed wire loop. Initially, people, they laughed on them, and even somebody has commented on Michael Faraday's experiment stating that what is the use of this small induced EMF? Yes, it was questioned and it was said that what is the use of this small induced EMF? Then Michael Faraday questioned in return that what is the use of a small baby? If you say that, what is the use of this small induced EMF, then what is the use of a small baby? And later, gentlemen, later, his experiments, Faraday's experiments, led to the, you can say, invention of transformers and generators, which brought revolution in electrical field. It was, the experiments were conducted at that time when there were no lights, when there were no full-fledged electricity available for lighting various objects or the bulbs. Experiments were conducted at that time. So Faraday's experiment and Joseph Henry's experiment brought a revolution in the life of each and everyone in the society. And now we can see that what is the use of transformer and generator. The light which is coming to our home, to our buildings, everything is through transformer. Whenever light goes, we run to start the generator. Why? Because we are not able to stay without electric supply, without electrical current. Generator is a device which generates electricity, right? Which generates electricity. It means which converts mechanical energy to electrical energy. So this is some introduction. Now we will go for the experiments. What the experiments he conducted. I am going to erase all what I have written here. Okay. And then we'll go for the experiments. Now before that, I will tell something about magnetic flux. Magnetic flux, which is denoted by phi. And magnetic flux phi is B dot A, right? B is the magnetic field and A is the area vector, right? Area vector. So if there is a surface having area A, and if the magnetic field is in this direction, so the normal to the space, normal to the space, surface, normal to the surface, that is N, will form or will be at an angle with B. Okay. So we can say that magnetic flux are the lines of force. These are lines of force. Okay, these are lines of force. So magnetic flux can be defined as the number of lines of force passing through a given surface of area A. The number of lines of force passing through a given surface of area A is called magnetic flux. Associated with that surface. So when there is a change in magnetic flux, an EMF is generated. So what is the finding of Faraday's law? That when there is a change in magnetic flux associated with the loop, EMF is generated, and that EMF is called induced EMF. Understood? And the unit of magnetic flux, phi, is Weber, denoted by WB, Weber, and 1 Weber is equal to 1 Tesla meter square. Tesla is the unit of magnetic field. So 1 Tesla meter square is the SI unit. We can say that SI unit of magnetic flux. So magnetic flux you have understood now. Now we will discuss the experiments. So the 3 experiments which were conducted by Faraday and Joseph Henry, we are going to discuss now. In that very first figure, you can say, first experiment, in that a wire loop is taken, a closed wire loop is taken, and that closed wire loop is connected with, the 2 ends of that wire loop is connected with a galvanometer. Then what is a galvanometer? A galvanometer is an electrical instrument which is used to measure very small current, minute current. There is a difference between ammeter and galvanometer. Ammeter is used to detect large current, whereas galvanometer is used to detect very small current. It is highly sensitive, very small current. So, a closed wire loop is connected, a coil is connected with a galvanometer, and when a bar magnet, this is a bar magnet, when a bar magnet is moved towards the wire loop, towards the coil, at some speed, it is found that the galvanometer has shown deflection in a particular direction. So when the north pole of this magnet is moved towards the coil, suddenly at some speed, it is found deflection. It means an induced EMF is generated in the coil, and which in turn has generated induced current. Similarly, when the magnet is pulled back with a jerk, again galvanometer has shown deflection, but in opposite direction. It has shown opposite direction. Similar case, even if the pole of the magnet is reversed, south pole is moved towards the coil, Again, deflection is observed in galvanometer. And similarly, when it is pulled back, deflection is observed in opposite direction. In opposite direction, it means it reverses its polarity. So this was the first experiment where a bar magnet is moved towards the coil, closed loop. In second experiment, this is the second experiment, in that bar magnet is not moved. Bar magnet is removed or replaced with a current carrying coil. Yes, current carrying coil. So here in that first experiment, the first coil is named as C1. The same C1 coil is placed and another coil C2 is taken in which current is flowing. A source of EMF, that is battery, is connected to the coil C2, and that current carrying coil, when it is moved suddenly at some speed towards the coil C2, the galvanometer had shown deflection. It means an induced current is set up in the circuit in the coil C1. And when the same coil is pulled back suddenly, again the deflection is observed in the galvanometer, but in opposite direction. See, the main thing here is, if the two coils C1 and C2 are kept stationary, if the C2 coil is kept stationary, even if the current is flowing in coil C2, no deflection is observed in galvanometer which is connected with coil C1. The deflection is observed only when the coil C2 is moved towards the coil C1 at some pace, at some speed. And in this process, there used to be a change in magnetic flux. There is a change in magnetic flux. And again, the galvanometer has shown deflection. It means that induced EMF is generated, and it is found that it can be given a mathematical expression as d phi by dt. d phi is change in magnetic flux per unit time. Per unit time. So this was experiment C2. Another experiment, C3, third experiment which was conducted, okay, in this, again the coil C1 and C2 is placed. The coil C1 is again connected with the galvanometer as it is. In all the three experiments, coil C1, setup of coil C1 is as it is. No change in setup of coil C1. The only changes are taking place in various experiments are, in first one, bar magnet is taken. Again, if bar magnet is stationary, there is no change in magnetic flux associated with C1, and hence there is no current. So movement is necessary. Right? In figure 6.3, third experiment, the current carrying coil C2 is taken, but it is connected with a tapping key. Tapping key, which is a switch, electrical switch. Now, when in the first instance, that electrical key was kept in open position. means no current is flowing in coil C2. Hence, there is no change in deflection of galvanometer, and it shows that there is no induced current. Now, when in first case the tapping key is pressed, tapping key is pressed. In the initial time, when the current started flowing through coil C2, galvanometer showed deflection. Galvanometer showed deflection. And when the current got stabilized after some time in C2, again the galvanometer deflection came to zero position. It means when a stabilized current is flowing through coil C2, there is no deflection and hence no induced current is set up in coil C1. Now, second, when the tapping key is opened, means the circuit is kept opened, suddenly the current is made to collapse in C2, is to fall down in C2. It is stopped. Again galvanometer, tapping key is opened. Tapping key is opened. The current is allowed to collapse in coil C2. Immediately the galvanometer showed deflection in first few seconds. So that shows that when the tapping key is pressed and till the time taken by the stabilizing current to get stabilized here in coil C2, there is an induced EMF in coil C1. The moment current has got stabilized in coil C2, the galvanometer showed zero deflection in coil C1. Similarly, when the tapping key is opened also and we are allowing the current in the coil C2 to get reduced, to get collapsed, to come to zero position, a deflection is shown in the galvanometer in opposite direction in coil C1, and when the current totally stopped in coil C2, the galvanometer also stopped showing deflection. Right? So this mathematical expression, all the three experiments have shown that there is an induced EMF is generated whenever there is a change in magnetic flux associated with the closed circuit. And the magnitude of induced EMF, E magnitude, E is equal to d phi by dt. Later on, it was named as Faraday's laws of EMI, electromagnetic induction. So the first one is, whenever there is a change in magnetic flux associated with a loop, closed loop, an induced EMF and hence induced current is set up in the circuit. Induced EMF. Second law says that the magnitude of induced EMF can be obtained by using the mathematical expression E is equal to d phi by dt. Now, to find the direction of induced EMF, to find the direction of induced EMF, let me erase it. Now coming to direction. of induced EMF or induced current. So here came Lenz's law. So what is Lenz's law? Lenz's law states that the direction of induced current is such that it opposes the cause which generates it. So the direction of induced current is such that it opposes the cause. It opposes the cause which is generating it. Right? Means it will be in opposite direction. So when a north pole of a magnet is moving towards the coil C1, it means this is the cause which is bringing a change in magnetic flux. So the direction of induced current will be opposing this motion, opposing that EMF, and the direction of induced current will be anti-clockwise in the circuit. It will be anti-clockwise when the bar magnet is moved towards the coil. When the bar magnet is moved away from the coil, the direction of induced current will be clockwise. The direction of induced current will be clockwise. And that is Lenz's law. Due to its opposition, Lenz brought that it is opposing, the induced current will oppose the cause which is trying to generate it, and due to which that induced EMF will become negative, that is minus d phi by dt. Minus d phi by dt. So minus phi 2 minus phi 1 by t2 minus t1. If there will be a number of turns, if there are number of turns in a coil, in that case the induced EMF will take the value of minus n d phi by dt, whereas n is the number of turns. Number of turns in the coil. So this is all about electromagnetic induction, which I have brought today as an introduction part to understand what is an induced EMF and the Faraday's 3 experiments which are important. And based on the mathematical derivation of the formula, induced EMF E is equal to minus d phi by dt, and hence we can also find out induced current is equal to E by R. E by R, V is equal to IR with that formula, and R is the resistance associated, resistance in the coil, resistance connected in the coil, in the circuit. So I is equal to epsilon by R. In next video, we will solve some of the questions related to electromagnetic induction. If you have enjoyed the video, kindly do not forget to share with your friends and press the like button, bell button and subscribe to my channel. Thank you. Thanks to all of you.